Hi, Mr. Richards here. Today's lesson is on roots, and we'll start with the vocabulary startup. A square root of a number is one of its two equal factors. Numbers such as 1, 4, 9, 16, and 25 are called perfect squares because they are squares of integers. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. Now, square root. I think this word means, and for this, let's just write in the opposite. Of squaring. Are there any parts of the word that I recognize? Sure. I recognize square. Root might be new, but how does this word fit with other words and concepts I know? Well, I know about exponents. And what makes this an important word for me to know? Well, if square roots are the opposite of squaring, basically I can undo squaring a number. And what is the relationship between squaring a number and finding the square root? Well, just like addition and subtraction are inverse operations, and multiplication and division are inverse operations, squaring a number and finding a square root are inverse operations. Now for our real world link. The square base of the Great Pyramid of Giza, I think, covers almost 562,500 square feet. How could you determine the length of each side of the base? When we really think about it, area is equal to side squared. So if we're given the area, could the square root of the area equal a side? Well, it does. And so what we can write for this is find the square root of 562,500. So if we're given the area and we're looking for a side, we can just take the square root of an area, at least when it comes to squares. Let's continue on. Our first key concept is that of square root. A square root of a number is one of its two equal factors. So if x squared equals y, then x is a square root of y. 5 squared equals 25, 5 times 5. So 5 is a square root of 25. Every positive number has both a positive and negative square root. In most real-world situations, only the positive or principal square root is considered. A radical sign, this square root sign or radical sign, is used to indicate the principal square root. If n squared equals a, then n equals plus or minus the square root of a. So let's find in our guided examples what we're doing here. Find each square root. Well, the square root is 64. Think, what number times itself is 64? Well, 8. 8 squared is 64, so the square root of 64 is 8. Then we get into this decimal. But before you get too freaked out by a decimal, think to yourself, well, 121. If I took the square root of 121, 11 times 11 is 121, so that square root of 121 is simply 11. Well, notice what they did here. Square root of 120, or 1.21, or 1 and 21 hundredths, was 1.1. So one way of looking at this is to find the square root of 121 The decimal point was here, and so 1.1. And then we have a square root of a fraction. Well, not too terribly hard. What they did here, what is the square root of 25? 5. What's the square root of 36? 6. And so if you take the square root of the numerator and the square root of the denominator, you get the 5/6. Now, don't forget the negative sign. Now, the square root of a negative number. There is no real square root because no number times itself is equal to negative 16. 4 times 4 is 16, but the only way to get to negative 16 is to do negative 4 times a positive 4 or a positive 4 times a negative 4. Those are different factors. 4 and negative 4 are different factors. And so because of that, no number times itself is equal to negative 16. Now what about our got it questions? Well, we have the square root of 9/16. And for this, let's take the square root of 9 over the square root of 16. Well, the square root of 9 is 3. The square root of 16 is 4. So the square root of 9/16 is 3/4. Now we have this plus or minus square root of 0.81. Well, the square root of 81 is 9, and so the square root of 0.81 is going to be 0.9. That's 0.9 times 0.9, or 9/10 times 9/10 is 81/100. Now we don't want to forget, in our question we had the plus or minus, and so we need to have our plus minus in our answer as well. Now the negative square root of 49 we're allowed to do, because it's the square root of 49, which is 7, and then the negative sign makes it negative 7, so negative 7 is our answer. And the square root of negative 100, well, for this there is no real solution, because nothing times itself is going to be negative 100. Now what about equations? Solve t squared equals 169, check your solution. We're going to take the square root of both sides to simplify this. Remember, squaring a number and taking a square root of a number are inverse operations. So, what about our example? If we take the square root of both sides here, we're going to end up with plus or minus 17 equals A. So our answer is plus or minus 17. What about m squared equals 9/100? Take the square root of both sides again, and m is going to equal plus or minus, what times itself is 0.09? Well, 0.3. Or 0.03, sorry, 3/100. So plus or minus 3/100 is our solution. What about y squared equals 4/25? Well, again, take the square root of both sides. And here, y is going to equal plus or minus, and we'll just break this down, the square root of 4 over the square root of 25. And so y is going to equal plus or minus 2 over 5. This is the square root of 4 is 2, and the square root of 25 is 5. So plus or minus 2/5. Our next key concept is cube roots, and a cube root of a number is one of its 3 equal factors. So if x cubed equals y, then x is the cube root of y. Numbers such as 8, 27, and 64 are perfect cubes because they're the cube of integers. 8 equals 2 times 2 times 2, or 2 to the third. 27 equals 3 times 3 times 3, or 3 to the third. And 64 equals 4 times 4 times 4, or 4 to the third. The symbol cube root is used to indicate a cube root of a number. You see the little 3 there. Now you can use this relationship to solve equations involving cubes. So in our guided examples, find each cube root, The cubed root of 125, ask yourself, what times what times what is 125? And a lot of this might be trial and error. I mean, if you did 4 times 4 times 4, we just saw that was 64, and that's too small. So if you do 5 times 5 times 5, that's 125. And so the cube root of 125 is 5. Now, we can do negative cube roots. So the cube root of negative 27, that is negative 3. As negative 3 times negative 3 times negative 3 is a negative 27. So when we get down to the cube root of 729, again, trial and error. Ask yourself, what times what times what is 729? I'm going to start big. I'm going to start with, 10. 10 times 10 is 100, times 10 is 1,000. That's too big. Let's try 9. 9 times 9 is 81, times 9 is 729. So this is going to equal 9. Then the cube root of negative 64. Not the square root, but the cube root. What times what is 64? Well, that was 4, as we can see above. So this answer is going to be negative 4. What about the cube root of 1,000? Well, we just did that back in H when we were trying with our 10. 10 times 10 is 100 times 10 is 1,000. So this is going to be 10. Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil. Solve the equation 8 equals s to the third to find the side length s of the container. Well, notice how they took the cube root of both sides here. The cube root of 8 is 2, so each side of the container was 2 feet. So as we move on to our last example, our got it question, an aquarium in the shape of a cube that will hold 25 gallons of water has a volume of 3 and 375 hundredths cubic feet. Solve s cubed equals 3.375, or 3 and 375 thousandths, to find the length of one side of the aquarium. Well, for this, let's go ahead and set up our equation. S cubed equals 3 and 375 thousandths. And we're going to take the cubed root of both sides. And this one's a little trickier. But I can tell you that 15 times 15 times 15 is equal to 3,375. And so using that logic, 1 5/10 times 1 5/10 times 1 5/10 is going to be equal to 3 and 375 thousandths. So our solution here is s equals 1 5/10 feet. And that is it for this lesson on roots. Good luck.